Continuing on in our 9.2 lesson, we're going to be looking at polynomial denominators of adding and subtracting our rational expressions. So the first thing to do with these rational expressions is always factor them out. So we have x plus 10 over, we can take the 3 out, x minus 5 right here, minus this fraction. We can take the 3 out of the numerator as well, x plus 5. We take the 6 out of this piece and we're left with x minus 5. Now we just need to find the common denominator between these two. And notice we have a similar binomial in here. We have that x minus 5. So we don't want to change that. We can just look at our coefficients, 3 and 6. Well, to get 3 to 6, we just multiply by 2. So we have to multiply numerator and denominator of this piece by 2. So our numerator becomes 2x plus 20. Everything becomes the same common denominator, 6 times x minus 5. And then we just carry this part through the negative, or minus 3 times x plus 5. Because this is all considered one term up here, when I distribute the negative piece, I just have to do it to the one piece. So it's not negative 3 and negative x minus 5. No, we just do it all at once, just the negative 3 times x plus 5. Now from here, we simplify a little more by distributing this negative 3 to the binomial. So we're left with 2x plus 20 minus 3x minus 15, still all over 6x minus 5. Gives a little more room to work with. Oop, too much. There we are. Now simplifying these down, 2x minus 3x becomes negative 1x. 20 minus 15 becomes positive 5. And still a 6x minus 5. Out of the top, we can pull out that negative 1. So it becomes negative 1x minus 5 over 6x minus 5. And we can divide out the x minus 5s, which means we're left with negative 1/6 is the most simplified version, or the reduced version, of our rational expression. So good job with that one. Now we're going to try the same ideas, only working with complex fractions, which, remember, are kind of our fractions within a fractions. So notice how both our numerator and our denominator have fractions this time. So first thing we want to do is break it into a division problem. 1 over a plus 1 over b, all of that divided by 1 over b minus, we're going to call 1 over 1, just so we have all fractions to work with. Okay. From here, we're going to look at this piece first. I'm getting that one into a single fraction. So we have a and b, so obviously our common denominator is just going to be ab. So we would say that to get this side there, we just have to multiply by b. To get this side there, we multiply everything by a. So we would have b times 1 is b, plus sign in the middle, 1 times a is a. So this is now our left fraction. Still divided by in there. Now we're going to look at this piece. Our denominators are b and 1, so obviously our least common denominator then is going to be b. To get there, we had to multiply this side just by 1, so it stays. Everything just stays the same. This side we have to multiply by b. So we would say then that it's, as a fraction, 1 minus b over b. So this is what we're working with. Now from here, because it is this division problem, we have to switch it into a multiplication problem. And remember, to do that, We keep our left one the same, b plus a over ab. Change it to a multiplication problem and do the reciprocal, b over 1 minus b. Now from here, we can do our diagonal division, diagonally crossing things out, b and b. Remember, this is one factor on its own, and this is one factor on its own. So we can't necessarily cancel anything else out. So this is what we're left with in the end, which comes out to b plus a on top over a times 1 minus b. So you can leave it this way, or if you really want to distribute, that's fine as well. You can have b plus a on the bottom and a minus a, or b plus a on top as our numerator, and a minus ab as your denominator on bottom. Either of these work as a simplified version of our rational expression.